In our previous lessons, we were going over how we use trig to solve for a side. In this lesson, we're going to be doing the opposite and solving for an angle. So if we remember, the sine, cosine, and tangent are all functions. So we have inputs and we have outputs. The input when we're dealing with the trig is always an angle measurement. And when we put in an angle measurement, we get something telling us about the size. Now, if we're solving for the angle, right, so we're usually going from angle to sides, right, in and out. If they ask you to solve for an angle, you're basically flipping this. You're doing the opposite. And when we do the opposite, that is what we call an inverse function. So before, we would have said, okay, the sine of A, which is an angle, gives us sides. But now if you're given sides and you do the inverse, you will get the angle back. Same thing for cosine of A is equal to usually the adjacent over the hypotenuse. Now, if you have the adjacent and the hypotenuse, you can do the inverse to find your angle. And the same thing for tangent. Your input is now your ratio, and your output is the angle measurement. So for example, if I am solving for x and I am solving for an angle in this problem, you will need to use inverse trig in order to solve it. So if I look here, right, here's my angle. I have the opposite and the hypotenuse measured. So normally it would be sine of x is equal to opposite over hypotenuse. So our x is over here, so I know that I need to use inverse, right? So if I take the inverse of both sides, I'll be left with x is equal to the inverse sine of 7 over 25. And now all you have to do is use your calculator. I put a little note down here. You're going to hit second, sine, and then you're going to do 7 over 25, enter. And if we round to the nearest tenth, so originally you should get 16.260 ... And if I round to the nearest tenth, I should get 16.3 degrees because this is an angle measurement. Now the next couple, I'm just having you practice actually put in the inverse. So you're going to do second sine 1.5 divided by 2.4. And if we round it to the nearest degree, so it's 38.6, which turns into 39 degrees. Now, inverse of cosine, so second cosine 1.5 divided by 2.4, 51.3, so that rounds to 51 degrees. Then inverse of tan, 1.5 over 2.4, which gives us 32 degrees. Now we're going to keep practicing. So second tan, 15 over 13, which gives me 49 degrees, rounded, of course. Second cosine, 2 over 9, which is 77 degrees. And then finally, we're doing the inverse of sine. So second sine, 8 divided by 15, which is 32 degrees. Now, if you're given a diagram, you have the extra step of having to identify which inverse function you would have to do. So if I look here, here is my x. So I know that I'm going to have to do an inverse function using what I have labeled. So I have my opposite and my hypotenuse. Opposite and hypotenuse is so I'm going to do the inverse sine of the ratio that I have given, 15 over 24. So second sine 15 over 24, and if we're rounding to the nearest tenth, we should get 38.9 degrees. And we're going to continue like that. So here's my angle. 8 is adjacent and hypotenuse, so we're going to do the inverse of cosine of 8 over 11. And if I want to round that to the nearest tenth, you're going to get 43.3 degrees. Number 3, 20 is opposite and not hypotenuse, opposite and adjacent. So this is going to be x is equal to the inverse tan of opposite over adjacent. So we're doing second tan, 20 divided by 37. Rounded to the nearest tenth, you're going to get 28.4 degrees. Number 4, again, I'm marking the angle. 18 is adjacent, 23 is hypotenuse, so that is cosine. So we're doing the inverse cosine of 18 over 23. So second cosine 18 divided by 23. We get that x rounded is going to be 38.5 degrees. Here's my angle. This is opposite and hypotenuse. So the sine, so x is equal to the inverse sine of 40 over 41. So second sine 40 over 41. We get that x is equal to 77.3 degrees. And the last one on this page, we have opposite and adjacent. So x is equal to the inverse tan of 7 over 5. So x will be equal to 54.5 degrees. So the next 2 pages are a bunch of practice. So let's look through these. So here is very simple. The first part is that we're just taking the inverse of what they give us to both sides to sort of cancel these out. So all I'm going to be doing in these is literally just doing the inverse function of the number on the other side. So for the first one, I'm doing second sine of 0.4848 and rounding it to the nearest degree. So b is going to be about 29 degrees. Again, I'm doing the same thing here where I'm taking the inverse function. So second sine of 0.5150 to get 31 degrees. 3, again, so we're doing second cosine of 0.7431 to get 42 degrees. Again, I'm rounding from the calculator. You should get a longer decimal, but just for the sake of time. So here we're doing inverse of cosine. So cosine, second cosine 0.6157. You get about 52 degrees. 5, again, we're going to be doing second cosine 0.5878. We're going to get 54 degrees. We have tangent, so we're going to do the inverse. So inverse tangent of 19.0811. And we're going to get 87 degrees. Again, this is all rounding. So originally we have cosine, so we're going to do the inverse to both sides. A turns into itself. And we're going to do inverse cosine of 0.4226, which gives us 65 degrees. And then we have w, which has tan, so we're doing inverse of tan of 0.5317, which gives us 28 degrees. So this first section was just practice actually plugging in using the inverse function. Here, the extra step is just identifying what function you would have to use. So here's our x. We have opposite and adjacent. So x is going to be equal to the inverse tan of 27 over 38. So I'm just going to plug that into my calculator. And we're going to round to the nearest degree. So it's going to be 35 degrees. For 10, 9 is opposite, 21 is adjacent. So again, we're going to use tangent. So the inverse tangent of the opposite over the adjacent. So we plug that right into your calculator. And you're going to get 23 degrees. Marking up my diagram, again I have opposite and adjacent, so x is equal to the inverse tangent of 14 over 29. So in your calculator, second tangent, 14 divided by 29. X is going to be equal to 26 degrees because we have to round up. For 12, I have opposite and hypotenuse. So here's a different one. We're going to use the inverse of sine. Opposite is 40, hypotenuse is 42. We're going to plug that into your calculator. So second sine 40 divided by 42, which gives us 72 degrees. Number 13, we have opposite and hypotenuse. So we're going to do the inverse of sine of 10 over 39. So second sine 10 divided by 39, which gives us x is equal to 15 degrees when you round it. And for our last one, we have opposite and hypotenuse again. So we're doing second sine 11 over 27, which gives us 24 degrees. So your homework for this lesson is page 20. So you're just continuing with the same things that we've been doing, identifying this is the opposite and hypotenuse. So x is equal to the inverse sine of 12 over 24. So we do second sine 12 over 24, which gives us 30 degrees. Here we have adjacent and hypotenuse. So x is equal to the inverse cosine of 13 over 20. So second cosine 13 over 20, which gives us 49 degrees. 6 is adjacent, 8 is the hypotenuse, so we're doing x is equal to cosine the inverse of adjacent over hypotenuse. So second cosine adjacent is 6, hypotenuse is 8 for 41 degrees. We have adjacent and hypotenuse again, so x is equal to cosine inverse of 4 over 5. So second cosine 4 over 5. To get x is equal to 37 degrees. Number 19. Here we have everything labeled, so you have a choice. You just have to make sure you're using the correct function. Well, I know 14 is opposite and 50 is adjacent, so I can just do x is equal to the inverse sine 14 over 50. You also could use either of the other functions so long as your ratio is correct. So we have 16 degrees. Again, same thing. I like sine just because it's easier for me to make sure I'm using it correctly. So we're going to do opposite is 68. Hypotenuse is 85. So in your calculator, second sine 68 divided by 85. We get that x is equal to 53 degrees. So x is equal to inverse sine of our opposite side, which is 24, over our hypotenuse 25. Second sine 24 divided by 25. X is equal to 74 degrees because we round up. For number 22, again, I'm going to continue using sine just because it's the easiest one for me to see, because I just draw a line, I say, oh, that's the opposite. Oh, that's the hypotenuse. And then I just plug in using my calculator. So second sine 16 divided by 34. We get that x is equal to 28. So if you look at 23, our opposite side is 51. I labeled that wrong. Our opposite side is 51, however, our hypotenuse is 85. So in your calculator, second sine 51 divided by 85, x is equal to 37 degrees. So x here is equal to the inverse sine of 42 over 70. So we use calculator. X is equal to 37 degrees. Okay. So now pages 21 and 22 are not required because these are going over our previous lessons from last week about finding missing sides. However, this would be helpful for studying for your short quiz on the beginning of Intro to Trigonometry.